I think I am live now. Hello everyone. Today I would be discussing CodeChef Starters 127. It was rated till 5 star, and I was able to solve all problem except the last problem. So I would be discussing all the problems except the last problem. Just give me a minute, and probably people in the chat can say how many problems they were able to solve and which was the problem they found most difficult. I tend to start from I think within 5-10 minutes I would be done with the first three problems, and then I will start in this order. Okay, binary search one was tricky one, array operations searching. That's whatever the problem name was. I in fact wrote a comment that I think the model solution is wrong, but the setter confirmed that it's right. Okay, let's get started now. So the first problem says it was warned by Slothrayer to be wary of the ideas of March, namely 15th of March. Today is end day of March. Your task is to tell Caesar whether it is ideas of March so that he can take extra precautions if necessary. The only line of input contains integer and today's date in March. Print yes if it's ideas of March, no otherwise. Another yes if else problem where you have to take an input. If n is 15, you should print yes, otherwise no. And pretty much that was the idea for this problem. C in n, if n equal to 15, print yes, otherwise no. And this gives us an AC for this problem. And I will move to the next problem then, which is extreme basketball. Alice and Bobs are playing a game of basketball against each other, 1 versus 1. Currently, Alice has A points, Bob has B points. Each sort of a player can either score. Each sort of a player can either score 2 or 3 points. Alice isn't just out to win; she wants to win in the dominant fashion. Alice believes that her win is dominant if she ends the game with at least 10 points more than Bob. If Alice is able to prevent Bob from scoring any more points, what is the minimum number of shots she further needs to get a dominant victory? I hope my audio is fine. If in case there are issues, someone do just confirm it once. The idea is since now Alice has prevented Bob to score any more points, the number of points for the Bob is fixed. And during each shot, a player can score 2 or 3 points. Because you want to minimize the number of shots, it's always ideal that Alice gets 3 points on all the remaining shots she wants. What we can do is we can run a for loop and we can keep adding 3 points to it until the score becomes Alice's score becomes more than Bob. And this should solve our problem. There are other ways to solve it in order of one as well, but the constraints were really small to allow running a for loop like this. Wait one second. Okay, while Alice's score is less than 10 times Bob's score plus 10. We add 3 to Alice's score, we increase the number of shots we need to make, and that was the solution for this problem. We take the number of test cases as input. The other way would have been we would have taken the difference and we can write a number modulo 3. So the answer would be n divided by 3, and if remainder is less than equal to 0, we can take the difference of what is the final score we need and what is the current score. We can say required score is 10. Required more points would be minimum required points would be required score minus Alice score. If required more points is less than 0, we don't need any more shots. We output 0 and continue over here. You can say we can directly divide by 3, like the number of more sorts we need. And if there is a remainder, we should also increase count plus plus. Or like the other way would be like we can also do the ceil operation. Like this should also work for this problem. The idea is when the number becomes large, you should not use the mathematical ceil function. And like for a very large number, like the other way can be like this can be one way to do it. So like I will pretty much move to the next problem then. The next problem says super increasing. An array of length and containing positive integers is said to be super increasing if each element is strictly greater than sum of the previous element. For each I from I equal to 2 to n, the condition ai should be greater than sum of previous numbers should hold. For example, a equal to 3, 5, 10, 14 is a super increasing array, while 1, 3, 4 is not. Like let's look at this example once. If you look at the number of elements which are before 5, then their sum is 3 and 5 is greater than 3. Similarly, if we look at the numbers before 10, there are two numbers, their sum is 8 and 10 is greater than 8. Similarly, if you look at the numbers before 42, there are three numbers, their sum is 8 and 42 is greater than 18. So like this is a super increasing array. Like this greater than, this is greater or greater than equal? It's strictly greater, yeah. Saf has a super increasing array of length and with him a long time ago, but he has forgotten all the elements. The only piece of information he recalls is that the value x occurred at index x, that is array ak equal to x. Can you tell Seth if he recalls correctly? That is, does there exist a super increasing array of length and such that ak equal to n? So what the problem is asking us is, does there exist a super increasing array where ak is equal to x and there are some numbers after? Note that if this is a super increasing array, if we delete the numbers after it, then also like this part will also be a super increasing array. Because for this part also sum of numbers before it would be less than equal to whatever the required number is. So the idea to solve this problem is like we greedily try to find an smallest, we greedily try to find an array such that each number is as small as possible. So like what is the smallest possible value for the first number? Like first number must be 1, like because all the numbers are positive, I believe. Yes, all the integers are positive. So like 1 is the smallest value of the first integer. And like for the second integer, that second integer should be less than sum of all the numbers so far. Like second integer, like the possible value, minimum possible value for the second integer is 2. And now the idea is like what is the smallest possible value for the third integer? Like if you see like sum of these numbers is 3. So the smallest possible value for the third integer would be 4. And if you try further, like what should be the smallest possible value of the fourth element? Like sum of these elements is 7. So here like the smallest possible value would be 8. And you can see like so on. Like the next smallest value would be 16, 32 and so on. And like once we notice this, let's say like we want to create an array with length 4 over here. Let's say we need a4 equal to 10. Then what we can do is like we can take this array and we can change this 8 to 10 and like we can in the same way we can either increase the remaining numbers. So if a4 is greater than 8, then the answer is yes. And if a4 is less than 7, the answer is no. Because we have figured out that the smallest possible value for the fourth element is 8 over here. And pretty much that is the idea. Now you can see like once you print the first 40 number, then you will have a41 is greater than equal to 2 to the power 40. And like this number is greater than 1e9, what was given to us to input. So now what we can do is like we can greedily try to create this array. Whenever our current number becomes greater than x, we break. Or if our index becomes k, then we check if current number is less than equal to k. And like that would be the idea for this problem. So I will start creating the array. And like I haven't read the full complete problem statement, but I think like everyone have read it. So the idea is like we can try to create an empty array. Like the smallest possible number is 1. While a dot size is less than x, we find what is the current sum so far. And we push like the next element sum plus 1 over here. And like let's just create like whatever element we if like we can also say like if sum plus 1 becomes greater than like whatever a dot size should be less than k. If current value becomes greater than k, then we can break again over here. And at last we can check like the last value of a is less than equal to x. We print yes, otherwise we print no. And like that would be the idea for this print. Yes, if k is greater than 31, we can directly print no. Yes, like I'm sure like x greater than equal to 2 comma power 1 would also work. And yes, Rishabh, you are also right. We can directly check log 2 of x should be greater than equal to k. And pretty much that was the idea. The way I did it was like it was, I think, a Div3 problem. So I felt like running it a for loop and showing it like the way to think it would make it easier for the people who are not able to solve this problem. Okay, once is asking, can you look at my code after this discussion? I think the best way would be like you can join the Discord server, link is there, and you can send your code link there, and I will probably take a look at it. If it's not readable, then I will probably skip it. But if it's readable, I will take a look at one glance over it and try to see like what would be the mistake. Okay, now any questions on the first three problem before we move to the problem which were rated in Div1? But I think all of these problems were also rated in Div2. Superincreasing was the first problem in Div2. Okay. Okay, I will move to anti-triangle problem. Okay, I will take questions like once I'm done with the discussion. Like if there are any questions from the audience, I will try to answer them before completing the stream for today. Okay, yeah. Seth has a wooden branch of length L. Seth also loves triangle, so he would like to obtain 2 more branches. Arrange them in a shape of rectangle that he can admire forever. Seth set out to be out to the nearby woods, determined to find appropriate branches. There are n branches lying around in the wood. The ith branch, which has length ai, all of these lengths are distinct. That is, no 2 branches have same length. But none of the lengths exceeds 1 in 9. Shockingly, Seth could not take any pair of these branches to form a rectangle with his existing branch. Can you give an example of lengths of the branches Seth saw? Formally given integers n and l, find an array of length n such that each ai is from 1 to 1 in 9. ai is not equal to aj if I is not equal to j. Any pairs I and j such that I is less than j is less than equal to n. It is impossible to form a rectangle with positive area whose sides are ai, aj, and l. You may find like this is the hint given to us. You may find the triangle inequality helpful. That is, 3 positive integers x less than y less than equal to z can form sides of triangle with positive area if and only if x plus y is greater than z. It can be shown that under given constraint, a solution always exists. If there are multiple solutions, you can print any of them. So probably let's first see like what is the problem statement asking us to do. So it says if we are given two integers and an n, we have to find an array of length n such that if you pick any two numbers from all the numbers should be distinct, like all the numbers should be different. Let's say we have picked these two numbers. Like we should try for all the possible pairs. So there should not exist a triangle with sides AI, AJ, and L. They are also given like if we look at three sides of triangle x less than y less than z. In the only like if you have a triangle with sides x, y, and z, and if you take the sum of smaller two sides, if it is less than z, then the answer is yes, it is possible to form a triangle. Or otherwise no. So what we need is like if we let's say somehow sort our given array, or like let's not just sort, like any ideas from the chat, like how can we approach this problem? Like what we need is like whenever we take any two numbers from our given array and we add L to it and make them in the increasing order, then the sum of smaller two numbers should be less than equal to the largest number is what we need. Because if this happens, then it's not possible to form triangle. Any ideas in the chat? Okay, just create an array using a plus b less than L. Yeah, that can be one solution. Okay, so what we need is like one thing we can do is like we can make L the smallest number, and our array, the smallest possible number in the array can be 2L plus 1, 3L plus 2, or like probably let's just add multiples of L plus 1. So the number would be L plus 1, L plus 2, 3L plus 3, and so on. And like if you see, like if you pick any two numbers from here, your chosen numbers would be the largest one. Like let's say you have chosen AI equal to I into L plus 1 and AJ equal to J into L plus 1, and let's say I is less than 1. Then your shortest order would be L less than I into L plus 1 is less than J into L plus 1. And like now if you take the sum of smallest two numbers, like this sum would be I into L plus 1 plus L, and you can verify this is less than equal to J into L plus 1. So like the answer is no in this case. Like if you put n elements of L plus 1, then like it would definitely be the case that if you took any two numbers, then the difference would be more than L. So the answer is n in this case. So this is one possible solution. But what is the problem here? Like you can see, like our final number would be n into L plus 1. And if you look at, let's say the constraint is L equal to 10 to the power 8 is given to you and n equal to 10 to the power 3 is given to you, then this number would be around 10 to the power 11 plus 1003, and this number is greater than 10 to the power 9. So like it would fail in this case. So like that is the problem we have. Like if we first look at n into L plus 1, if it is less than 10 to the power 9, we can print all the multiples of L1 plus 1. Like that is one solution. Like, so any ideas like what should we do if n into l plus 1 is greater than 10 to the power 9? The other thing you can note over here is like if n into l plus 1 is greater than 10 to the power 9 and maximum value of n is 10 to the power 3. So the minimum value when this happens, then L is greater than or equal to 10 to the power 6. Like I am taking some approximate values over here. What we can do in this case is like, if you look at the number 1, 2, 3, 4, let's say we take these numbers. Then maximum sum of any two numbers over here is 2 and minus 1. So if the case is 2 and minus 1 is less than L, then we can directly print the numbers. Like this is one other solution over here. Like one other solution, like there are many ideas for this problem. One solution is let's take the smallest n numbers. And this would be a valid solution. If we say like all the numbers are less than n, then if we pick any number, let's say ai equal to I and aj equal to j, then I plus j should be less than or equal to L for all the numbers. And the maximum possible sum you can get in this array is 2n minus 1. So if 2n minus 1 is less than L, we can also print the first n numbers over here. So like now we have two solutions. One solution is we print all the multiples of L plus 1. The other solution is we can print first n numbers. And there are different cases when both of them, when one of the solution works and one doesn't. So like if 2n minus 1 is less than L, then if we print first n numbers, we would be good. Or if n into L plus 1 is less than 1 in n, then we can print all the multiples of L plus 1. Important thing to note here was, based on the value of n, one of these solution will definitely work. And sometimes it can happen that both of the solution works. Sometimes both will work. And like this pretty much completes our idea over here. Like what we can do is, this is one solution. Our other solution is we print multiples of L plus 1. So my idea was, is less than L, I print 1 to n numbers from 1 to n, otherwise I print numbers, all the multiples of L plus 1. And at last, I am pushing it to the array, and at last I am putting these elements back. And like other way we can do is like, if n into L plus 1 is greater than 1 in 9, we can print these numbers. Otherwise, we can print these numbers. This idea will also work. Any questions on this one? Like the crux of this problem was coming up with two solutions and then realizing that one of them will work. The idea is if value of L is very large, then you can take the first n numbers and you would be good. And if value of L is very, and like basically if value of L is very large, then numbers less than L by 2 would be very large. So you can print numbers from this. Or if value of L is very small, then multiples of L plus 1 would be very large. So you can pick any n numbers from them. And like this was the idea for this problem. Any questions on this one before we move to the next problem? I will move to the next problem then. ABC conjugate. It says you are given two strings A and B, both of length n, containing only characters A, B, and C. In one move, you can modify A as follows. Choose three indexes I, J, and K, such that AI is A, AJ is B, and AK is C. That is, choose some subsequence of A that is ABC. Then swap the values of AI and AK. That is, turn the subsequence ABC into CBA. And now one example is given to us. Okay, the example given to us is a sequence CAC, BAC, and like it says if we take these numbers A, B, and C, and if we swap these A and C, our resulting sequence becomes C, 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 B, A, B. So it says we can do operations like this. However, as many examples as we want. I agree example test case is bad. I won't say it's bad, just that it's given that so you think about the idea rather than keep submitting when you get an issue. And it says we are given two strings A and B, and we have to do some operations, as many operations we want in A, and we should check if we can make A equal to B. So any ideas like how can we do these parts over here? I used EQ and worked. Yeah, like my idea is similar. I use Q and work. Like my idea was similar. Okay, for this I made the observation that when you swap A and C, prefix sum of array from index A to index B increases by 2. Can this logic be used? Like I am assuming like you have some values of A, B, and C or something like that. Okay, you are assigning A equal to 1, B equal to 2, and C equal to 3. So like I'm not really sure. Like I tried using a similar idea, but I was not able to see. Like at least I was not able to solve. Like I did try some similar ideas over there. Like if you look at my submissions, like I did made quite a lot of submissions once ago. Why does it show only 2 submissions submitted by me? I am pretty sure I made a lot of submissions. Not sure where did my submissions go, but yeah, let's go for that. So like the idea I had was like we can never change the we can never swap B, right? So if AI equal to B, then BI should also be equal to B. Like all the B's should be at same position. If there is a B and other position as A or C, the answer is immediately no. So we can make this check first. Next, the idea I had was like if like AI equal to BI, then we can ignore this index. then you will see like if you ignore all of these indexes, all of the index like this, and like for all the places where B appears, AI equal to BI holds, then the only places where you need sub swap is when either at some index A contains A and B contains C, or at some index A contains C and B contains A. Like these are the only type of swaps you need over here. Because you can either swap A, like whenever you move some operation, A gets replaced by C, and whenever and C gets replaced by A. So my idea was I can make a list of this index. I also make a list of this index. I also make a list where all BBs appear. I have these three lists. Then what I did was greedy. Take the first place where A appears in A and B appears in C. If you put these in set, like you can find the first index where BB appears, find the smallest index just after it where BB appears, and then after this find the smallest index where CA appears. Like you can use set dot lower bound to like, if you know this index and if you have like all these three lists in a set, then you can use lower bound function to find this BB here. And then you can also use lower bound function on the third set to find this CA. I keep finding the numbers like this and I keep swapping the numbers here. And at last, if I cannot find any such move, I make a break. And then I check whether A equal to B, both the strings are equal or not. And like this was the idea that pretty much worked over here. The main idea was like if there is a way to find A and make A and B equal, then for any index there must exist such CA as well. And like if you look at the numbers like this, you have some sets of AC and you have some sets of CA. And you need swaps in these numbers such that between any pair you choose there should exist a B over there. So like if a number exists like this, then like you would be able to match this A with this CA. You would be able to match this A with this CA. But when you try to match this number, you won't find a next paired CA for it. And similarly the other case it. And like this was the idea. Like the problem I would say was nice, just that it took me some quite a good amount of time to get in. So like let's just remove this array. Iterate on all the numbers. If AI is equal to BI, if any number is equal to BI, then if AI equal to BI, then I put these numbers in set where I'm putting all the B index number and continue. Otherwise, I say like it's impossible to make numbers equal and I do a break over here. If none of the numbers are AI, then if AI BI equal, I ignore this index. Then like this is the case when if AI is equal to A, then CI must be equal to C over here. So I put it in the set which I'm maintaining all the AC pairs. And if the other case is when AI is C and the other number is A, I put it in the vector with pair CA. And if there is no B in the array, like at first we can check if A is equal to B. Like we don't really need this check as well. If like there was a case when this number does not exist, we should print no and we should ignore it. Otherwise, what we can do is, as long as there is one AC pair, find the first index, then use lower bound on this to find the next index where B appears. If IT is equal to B, then there is no B after this AC pair. So we mark a break over here. Otherwise, my next B index would be like the position which I got from the lower bound. Then I can use a similar lower bound to get the next index for C as well. If I did not find any CA pair, I break. Otherwise, I have found a pair where AC exists at AC IDX. Then a B exists at this index. And then a C exists at this index. And like this is a valid sequence. So it's possible to swap this operation. So I swap them. And then I also delete these numbers from the set because now like A and B would be equal over here. And I keep doing it. At last, if A is equal to B, print yes, otherwise no. And like that is the idea for this problem. Mm-hmm. Any questions on this one before we move to the next problem for today? Yeah, like Q approach, I think would also work like. Okay, moving to the next problem. I think no one has doubt in this. If there are some, I can could be answer. Okay, area presence. Okay, let's move to the next problem then. The h index of an array is defined to be maximum integer h. Like whenever you see maximum integer or minimum integer like this, first idea that should click to you is like we can possibly use a binary search here, such that there are at least h elements in the array which are greater than equal to h. Now, like let's just look at this statement first. What we say is like if there are if an array contains at least 5 numbers greater than equal to 5 and 5 is such maximum number, then we can say that the array is 5 IDX. Like let's ignore this maximum part here. What we can see is like if an array contains at least 5 numbers greater than equal to 5, then we can also say that the same array contains at least 4 numbers greater than equal to 4. And we can also say that the same array contains at least 3 numbers greater than 3. So if you see, like if I give you a black box, like let's say I have a function, black box function, which takes some value, let's say h, and it says like let me just refresh. Like is it possible? Like probably let me just complete it in the problem. You are given an integer array A and a positive integer K. You can do the following operation as many times as you want. You pick two indexes I and J such that AI is divisible by K and AJ is not divisible by K. Then divide AI by k and multiply aj by k. Find the maximum possible h index of a that can be attained after performing the above operation as many times as you like. So like it gives us one operations. I will go through the operation later. Let's say we have a black box which takes an array A and takes a value h. And let's say this black box returns yes. If after performing some number of operations, it is possible to get at least h numbers greater than equal to h. Then you see like if let's say our final maximum index is 10, then black box a comma 10 will return yes. Black box a comma 9 will also return yes. Because after doing some operations, if you can make 10 numbers greater than 10, then we can say like these 10 numbers are also greater than equal to 9. And like the similar idea. Similarly, black box a comma 8 would also be written yes. But because 10 is the maximum number for this it holds, black box a comma 11 will return no. And black box a comma 12 will also return no. And like similar idea. And now like if you whenever you see a function like this which returns yes for some interval, and then it starts returning no, then the critical idea is like you can always do binary search to find where this yes to no changes, or like similar idea. So like that would be the first part for this problem. Let's say we have taken nk as input. I have some black box. I will look at this value later. And like we can always say like all the numbers greater than equal to 0 are greater than equal to 0. So like the black box will always return true for 0. And similarly, because we know that the array contains only n numbers, so it's impossible to get n plus 5 numbers greater than equal to n plus 5 over here, because array itself contains only n number. So like we first, in the binary search like this, we first make two boundaries. Because the arrays of form yes, 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 no, 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 our smallest value should be when we know that the answer is definitely yes. And the largest value should be when we know that the answer is definitely no. I have taken no and yes like this. As long as difference is greater than 1, I take mid. And then I check like whether my black box returns true for mid. If it's true, then you can see like we can jump our left hand side to mid place. And the idea would, the segment would still be yes, 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 no, no, no. Or if we have got the answer no, then we can reduce our right hand side boundary. And then when we would be done by this part, L will be the smallest index with yes. And R will be the smallest index with no. Sorry, L would be the largest index. The smallest is 0 always. So, and because I need the maximum index where the answer is yes, I am printing yes. So any questions on this one before we move on, like how to write this black box? Okay, black box was definitely difficult. Like I think I spammed a lot of submissions here, and I think this was the problem where I spammed more rather than the other problem. And like I don't know if my comments are visible, but I also ended up writing like probably the model solution is wrong. So the idea is greedy, but what greedy is the difficult part. Is it good practice to submit W? It depends on the contest. Like there is no penalty in this contest, at least as far as I am aware. So it's good. But if you look at code forces, your point decreases for each wrong answer. So it's bad idea to submit there. In lunchtime, in starters, there is no penalty for submitting wrong answer. So like you can always test your ideas. So like first, let's say we have number A. Like if we don't do any operations, like let's say we want to make at least h number. We want to make at least h numbers greater than equal to h. This is our black box, which will say yes if it's possible to make at least h numbers greater than equal to h, otherwise no. And we can call this black box again and again to move between, do the binary search again. Then the first idea is let's ignore all numbers greater than h. And we can directly add this to the count. Our idea is we will try to make as many numbers greater than equal to h as possible. And then we will look at like the numbers we have formed so far is greater than equal to h. If that is greater than equal to h, we return yes, otherwise no. First idea which comes to anyone's mind is let's ignore all the numbers greater than h and let's count numbers divisible by h by k and less than h. Let's call it, okay, let me define multiple counts here. We say like C1 is the count of number greater than h. C2 is the count of number greater than equal to h. Count of number less than h and divisible by k. And C3 is the count of numbers less than h, but if you multiply it by k, number becomes greater than equal to h. Because one thing you can notice, like it says like aj is not divisible by k. So you can multiply any number at max once, because after you multiply it by k, that number becomes divisible by k. And you can no longer perform any multiplication on it. Like only divisions would be allowed. If we have these three counts, then you can see like you can take C1 numbers directly and like minimum of C2 comma C3 over here. Because for every number like this, you can try to form a pair like this and you would get minimum of C1 comma C2 as the possible answer. Like this is the minimum possible count we can get it. If we do something more, it can happen that we can get some more idea. So my first idea was to simply look at this and check if it's greater than equal to h, print yes, otherwise no. And I think some of you would have tried it, like anyone in the chat who tried this idea and got a WA. So like this was the first idea. And the answer is like this gets a WA. And the main reason is AJ should not be divisible by k, but AI can be divisible by k multiple times. So it is possible to pick AI multiple times over here. Like the idea is like, let's say k equal to 10. And if AI is 1000, then we can pick it 3 times. So now instead of just counting the numbers less than h, we should count like how many times we can divide number of times we can divide by k for numbers less than equal to h. So the idea is if I can divide 1000 and if k is 10, I will add +3 here instead of just +1 which I was doing here. And then I can again look at C1 plus minimum of C2 and C3. If it's greater than h, then the answer is yes, otherwise no. Like this is one more optimization we need. Like if anyone tried this idea, like the thing was this idea also gets a WA. And the next WA I submitted over here was, you can see like we need only numbers greater than k. So I definitely took these numbers. What extra thing I did was, for numbers greater than equal to h, keep dividing by k as long as they are greater than equal to h. So the idea is like, let's say our h is 101 and AI is 10, like let's say AI is 10,000. So my idea was to like even k is 10 again. So my idea is to do even one operation on this one, because after doing one operation, number remains still greater than 1. But if I do second number, number becomes less than 0. So I also had these many counts in C2. So like the third idea I had is count the numbers greater than equal to h. For all the numbers less than equal to h, count how many times you can divide by k. And along with this, I also counted like for all the numbers greater than h, how many times I can keep dividing them by k as long as the number is still greater than h. And that would be my C2. C3 is the numbers. C3 is always fixed. The numbers which I can multiply by k, which are not divisible by k, and if I multiply them by k, number becomes such. So my solution is still C1 plus minimum of C2 and C3. And like at this point of time, like this looks definitely works. But the idea is this also fails. And now a counter test case why this fails. Like I will take one example. Let's say our k is 10 still. H is 100. And let's say the numbers are 9, 9, 9, 1000. Or okay, let's say the numbers are 11. Earlier, if you see, like I was dividing it only once to make it 100, and they make it this greater than 0. But the crux of this problem was sometimes it's optimal to make numbers which are greater than h less than h if it can give us extra operations there. So like if you see, like if you have three numbers like this, among all the ideas we tried so far, the max we would have got was this case. The answer would be 2. But like the main crux here is like you can divide this number again to make this greater than 0, and this number again to make this greater than 0, and overall you can get 3 numbers here. This was the number greater than h which we made less than h, and these 3 numbers were less than h but we made them greater than h, and overall the count was 3. Like the main idea is whenever you, like if you divide a number, like let's say k cube, then you can divide it by 3 times to get 1, and you can get 3 multiplication operations for it at the expense of removing one number from here. And like that was the final greedy idea. Like I maintained a separate array B where I maintain like how many times extra I can get if I divide the numbers greater than h by, I keep dividing them by k. And like that was the last idea. So like now I will jump onto my black box. I have similar 3 variables. Count is the number greater than h. dvk is the number of times I can divide, and multiply k is like number of times I can multiply by k to get the number greater than h. I have this some number B, array B, which we will iterate on the given numbers. Let's first say like if the number is greater than h, I simply make it count. If number is divisible by k, I count like how many times I can divide by k, and like that would be my dvk. If x into, like if this holds, I continue. Otherwise now x is not divisible by k, and if I multiply it by k, number becomes greater than or equal to k. My value is multiple k. And one more thing which I did was for numbers greater than h, how many extra times I can divide so that the number still remains greater than h. And like this idea looks fine so far. And at last, I take like minimum of how many divisions I can make, how many multiplications I can make, and I add that to the count, and I see if count is greater than h. This was the last idea before I tried to think of even divide the numbers which are greater than k. And now I have a separate count too. Like if I multiply this number and if I make it less than k, then like how many times I can get multiplication operations. So like if I now this one was the so far the idea when the number still remains greater than h. Now I am looking like I am fine if you reduce this number to make it less than k, but how many times you can get multiplication operation from it? So I keep dividing it, I keep adding count to plus plus, etc. So now if this count to is greater than 1, then at the expense of one number, I would be able to multiply count to numbers more over here. Like see, if you have k cube, then you can divide it by 3 times to make other numbers greater than k over here. And like that is the idea. Like I then push them into a vector, sorted this vector into a decreasing array, and like this was the first operation I did. If number becomes greater than equal to h, I am good. Otherwise, now I greedily pick from the maximum number of times I can get divided over here. So like for each b, like there would be one number that I no longer can increase it because I am making it less than h. And then the maximum number of division operations I can get would be the count to for this number. Like if I remove current number, then the count of number greater than h decreases by 1. But I can get count to more division operations. Then again, I took look at the minimum value of dvk, what all remaining number, multiple k remaining number. I subtract them from k, and like this would be the extra numbers I can get at the expense of making this number greater than h. And if this becomes greater than h, returns true. Otherwise, keep repeating the cycle. And at last, this is what I am taking. And like this was the last critical operation. Like there can be times when it's optimal to make the number greater than equal to h to 1 or as small as possible to get some extra multiplication operation for some other numbers. And once, like if you find out this observation, you would be able to get an AC here. And like this was the idea for this problem, and this finally gets an AC. Any questions on this one before we move to the next problem? Okay, moving to the next problem then. Like no questions on this question, or at least the black box part. Okay, we have 2 more problems remaining. Like it says, you are given a tree with n vertices. That is a simple undirected connected graph with n minus 1 edges. K of its vertices are colored black and other vertices are white. For every x equal to from 1 to k, solve the following problem. Find the expected number of connected component in the resulting graph. If you delete exactly k randomly chosen black vertices from the tree, each subset of x vertices has equal probability of being chosen. Deleting a vertex means you remove it and any edge incident to it from the tree. Print the answer modulo 1 in 9. Formally, some definition is given. So what the problem statement is asking us is, we are given a tree. This is how the tree looks like. and some of the vertices here are painted black. Let's call it orange because my background is green. 1 2 3, let's say 5 vertices are here. So like for each x equal to 1 to 5, you randomly choose a set of x vertices, like the number of possible sets is 5cx, and then you count the expected number of connected components in this tree. So for example, if you delete vertices, for example, if you delete this vertices, then you also delete the edges which are connected with this vertex. And like that would be the idea. Or for example, if you delete this vertex, if you delete this vertex, then these edges also go away. And the number of connected components is 4. Along with that, if you also delete this one, then also connected component is 4. So like one important cool idea for this problem was also it's given a tree. This does not need a DFS. So like how do we count the number of connected components? My idea is we have one equation. Is equal to number of nodes minus number of edges plus number of cycles is there. I'm not really sure like what exactly is the idea for this cycle here. Like either it's number of atomic cycle or something like that, but there is some function of cycles here. Like I can probably take a look at it. It's strange that I did not find a definition here. Let's just say like the third element is some function of cycles. Either it's number of elementary cycles or total number of possible cycles. I'm not really sure right now. Because it's given a tree, like we can never have cycles, so this part is 0. So what we need is for each edge, we need number of nodes minus the number of edges when you delete exactly k part. And because you want expected value, like you know that when you pick the number of nodes here, like if you pick delete x nodes, then the remaining number of nodes would be n minus x. So what we need is expected number of edges. And we know that originally there are n minus 1 edges. So expected number of edges would be n minus expected number of deleted edges. So overall, like let's call it DEXP, like the expected number of deleted edges when we pick exactly x node. So like the number of nodes we have is n minus x. Minus originally we have n minus 1 edges. And from this, we would delete the expected number of edges. And if you simplify this, this equation becomes like this and cancels out. And the equation becomes 1 minus x plus DEXP. And now like each edge can happen 2 times. Either we pick the set in such a way that we pick both the endpoints of the set, like that can be one way. For any deleted edge, we deleted both endpoints, or we deleted only one endpoint for it. Like these are the 2 possible cases, right? For any deleted edge, either both the endpoints were deleted or only one endpoint was deleted. So like if we know that if we delete node y, let's say if we delete node 5, then the number of deleted edges would be d5, where d5 is degree of 5. So like basically, let's say if we have deleted node 1, 2, and 3, node 1, 2, and 4, my idea would be the number of edges we have deleted is degree of 1 plus degree of 2 plus degree of 4 minus all the edges which have both the endpoints in this part. So for example, if the graph was like this 1, 2, and 4, then when you count degree of each deleted node, you would count these nodes 2 times. Once when you are counting degree of 4 and once when you are counting degree of 2. So like if we have deleted 2, 1, 2, and 4, then we can directly take sum of 1, 2, and 4 and subtract it from number of edges between 1, 2, and 4, because they would be counted 2 times in the degree part. So like now when we are counting DXP, we need expected value of sum of degrees minus expected number of deleted edges with both endpoints in selected set. If we can get this part, then this would be my like expected number of deleted edges. This is sum of degree of nodes which we have deleted. And this is like the number of edges we deleted such that both the endpoints were in the deleted set. And along with that, if I look back, I should add 1 minus x to it, and that would be my answer. Like any idea so far before I go into like how do we find these expected to values? Because you see, like when we take sum of degrees, like both the endpoints would be counted 2 times. So we have to subtract that at least one. Okay, now moving further. First, let's find the expected sum of degree. Let's say black nodes are 1, 2, 4, 8, 10. And like what we can do is like for each number we can find that, like let's say we want to pick 3 nodes. Then the total number of possible sets would be 5 C3. And like what is the possibility that 4 is in the selected set? Like 4 would be in the selected set when we select 4 and any 2 numbers from the remaining numbers. So like the contribution, like this is the probability that 4 is picked. And when 4 is picked, the contribution in the degree would be that 4. And now you can take a sum like this for all the nodes. And if you see like this part, you can take out common. So overall, like expected sum of deleted nodes is equal to k minus 1 c x minus 1 k c x into sum of black nodes. sum of degree of black nodes. And like if you see like this probability will remain same if you want to find the expected probability that 2 is also selected. Or the expected probability that 10 is selected. Because if you want 10 to be selected among the 3 nodes we have chosen, then we have to choose 10 and random probability of any 2 nodes from the remaining set. Like total 4C2 is the number of sets which contain 10. And 5C3 is the total number of sets. So like this would be my first part where I am taking expected sum of degree. And now I also need the expected number of deleted edges which have both the endpoints in the given set. Like the next idea is also same. I first count the number of edges which have both the endpoints as black one. And like for example, if you pick one particular node with the endpoint, then if you look at it, the total number of sets would still be 5C3, and in denominator we need the number of sets such that both of these endpoints are selected. Because that would be the case when this edge would be counted twice. So if I have to pick 3 nodes, then like the idea is remaining among all the other nodes, I have to pick only x minus 2 nodes here. So in that case, like the number of sets over here would be 3C1. So basically, if there is some u, there is some v. So like the number of possible sets would be kcx. And if I want to count the number of selected sets in which both u and v were present, the idea is in remaining k minus 2 sets, I should pick x minus 2 numbers. So this is the probability that this particular edge was selected. That this edge was deleted twice. And if you see like this probability is same for any node which has 2 black endpoints. So I can take like if there are 5 such edges, probability of each of them is this. So if we take some 5 times, and overall we can do 5 into k minus 2 c x minus 2 and k c x. And like this pretty much completes the solution idea I had for this problem. Like I need like some values pre-computation of NCR, some pre-computations of NCR. Like then I first take as input, I take set V as of black edges as input. Then when I'm taking edges, I don't really need the complete set. What I need is like the number of nodes which have black, both the endpoints as black, and the degree of each node. So if both the endpoints are black, I increase the count of number of black edges by 1, and I also add degree of U and V. Now I need sum of black degree. So I iterate on all the nodes with black degree and I add their degree to my current sum. Like the number of nodes would be n minus, let's call it x. And like basically I can directly simplify 1 minus x. Plus the expected sum of degree would be And like, what was my formula? And I should subtract the edges which I have somehow counted twice. Number of black edges, and like both the endpoints were selected, like this would be the probability over here. And this pretty much completes the solution for this problem. Any questions on this one before we move to the next problem? Yeah, I agree. This one was hard. Like, even for this formula, some degree, like if you look at my screencast, I was earlier doing brute force, where I mentioned like DP, I, J, K's. Among the first black edges, I have deleted J black edges and their sum of degrees K. And only when I did a DP like at later, I realized it's simply the value is always constant over here. And like this black edge was, I was able to strike earlier first. So any questions on this one, or like any before we move to the last problem for today? Okay, I will move to the next problem then. This problem has subtasks, but okay. You are given two integers L and R. You have to purify each integer in this range. To purify an integer x between L to R, you must pay a cost, which is computed as follows. Choose a positive integer k and some integers a1, aj, ak, such that all the numbers are between L to R, and LCM of all the selected number is equal to x. The cost of purifying x using these integers is equal to max of all the numbers we have selected. And then some example is given, L equal to 12 and R equal to 74. So to purify x, we can choose segment 20, 30, 20, 60 with cost 60. Like if you look at LCM of these numbers, it's 60 and the maximum is also 60. But we can also choose 20 and 30. LCM of these numbers would be 30 and the cost is 30. LCM of these 20 and 30 is 60, so the and maximum is 30, so cost is 30. Or the other way to look at is like we can choose 12 and 20. Maximum would be 20 and LCM of 12 and 20 is 60. So, and like we can see, like there is no other way to get minimum cost 20. However, we cannot choose the segment 3, 4, 5, 12 because even if LCM is 60, all these numbers use the number greater than 12. And we have to find minimum cost to purify all the integers from L to R. There are two subtasks, L is equal to 1 and no further constraints. So any ideas on like how to solve for L equal to 1? Like the idea to purify any number is again greedy. Like if you see, like the cost is maximum of all the numbers we have selected so far. So for example, if we have 10, 20, 30, then we can also pick like, we can also pick 15. Like this can potentially increase the LCM and like the cost is still same. So the idea is for every number, greater than equal to L and put it in our set. If LCM becomes equal to L, then break. Otherwise, keep repeating the cycle. Pick the smallest number greater than L, which we have not picked so far, and put it into the set. And if you see, like because all the numbers are divisible by L, LCM can never be more than L, but after picking some numbers, there would be a case when the number becomes equal to L. And at that point of time, we will stop adding numbers, and whatever the max number we have added would be the cost. So like now if we run this algorithm, we can pre-compute the subtask when L equal to 1. We can pre-compute cost for each of numbers and use prefix sum, or like we can take the first R numbers and print that as a value. We don't need L if we are just solving the smallest number. So like to do this problem, I will remove all the extra things I have. Like I need divisors of all the numbers. I can run a sieve-like loop to get divisors of all the numbers in an array. I have defined n as the maximum possible value. And I have this function. Which takes like the value which we want and the smallest possible number we can get. And it will return us the required value over here. So what it does is it maintains like current max and the current LCM so far. It iterates on all the increasing order of divisors of V. If the number is greater than L, we ignore it. Otherwise, we replace LC equal to as LCM, and if LC becomes equal to 4, we return F here, whatever number we have got. Otherwise, let's say if it's impossible, I will return 0. No hard constraints on it. And you can see like if we call this number for each if we pre-compute everything, then when we want to answer queries, we can take L and R as input, and we can output ref R and OV. And like this should solve the first subtask for us. Okay, there is no function known as. I think yesterday this is one such method. Like let's just say like we know that LCM is LC into F plus GCD of two numbers. Let's just use this one. Rest in peace. Let's just partially correct, 20 points so far. Now the next idea. The idea is I will answer queries offline. So the basically idea is I will first compute the cost for all the numbers when L is 1. That's known as its C1, C2, C3, C4. Although L does not make any difference, so the cost is same if we say even if all the numbers are greater than equal to 1. Now like I want to update this cost and remove 2 from the sets if it is inoptimal. So that is like when you change from L equal to 2 to L equal to 3, like only multiples of 2 would be impacted. Any number, you can see like if it's not there, then it cannot be the LCM as well. And like that is my idea. Like I will run L equal to 1, 2, 3, 4, 5. Let's say if I am on L equal to 10, then I will update all the multiples of 10 so that now they're updated. I will use the same cost function to get a new cost when every multiple is at least 11. And I will update those values over there. And I will keep maintaining this array over there. And when let's say I want to answer for L equal to 10, then once I have removed, started from the set when L equal to 1 was there, then I removed all the multiples of 1 and made every number at least 2 in my set. Then I looked at all the multiples of 2 and removed 2 from their set and again found the minimum cost. Then I looked at the multiples of 3, removed 3 from all the sets, and I kept continuing on. Like when I am at 9, I have all the sets with values, everything greater than equal to 9. Now when I look at all the sets which can possibly contain 9, remove 9 from them and recompute the cost such that their cost is at least 10. Then I would be at the place where L equal to 10. Now if let's say I have to compute for 10 to 50, then the idea is I can take the range sum from 10 to 50 to get my final cost. Because you see it says AI is between L to R. So for any number X, when we want to purify it, we can always take X to get whatever cost we have got. And like this is known as sweep line idea. And like this was the final approach I needed. So instead of prefixum, my this cost function is still same. I first did all the queries, and for every query I maintain what is the R and what would be the query index for it. And I have created an answer vector of Q where I would compute cost for all the Qs, and at last I will print cost. Earlier I was instantly printing it. Now I have maintained a cost vector. The initial value would be cost V equal to V because every number can be greater than 1. And then I start from L equal to 1. I looked at all the queries that start from 1. I look at its R and I look at its Q. And let's say I can find range sum from L to R. I mark this as answer. Now I will start deleting from all the values from L. So I look at all the multiples of L. And like I can again find the new cost using the same method I have written, the same greedy idea. Iterate on all the multiples. If number is greater than whatever my L is, ignore it. Otherwise keep taking LCM. Whenever LCM becomes V, return it. That would be my new cost. And like this would be the idea. This is known as replay. And because I need range sum over here, what I did was I also maintained a Fenwick tree, which I have taken from AdCoder library. You can probably look at here. Fenwick tree. And like you can either use some method, you can also use segment tree, whatever you want. Like we just need some range sum. So initially when I am initializing it, cost tree, like now it's Fenwick tree idea, like you would be able to do it. And when I want to update the cost, I initially first subtract whatever I have added. And when I have got the new cost, I add it again. And like the index is like, this is the API to like, that is open interval. So I have added R+1 to get range sum. And like this pretty much completes the idea for this problem. The crux of this problem was to come up with a greedy, then realize that you can do it offline. Like instead of update, this should be get cost, updated cost. Like when I want to remove L, all the numbers should be at least L plus 1. And like this instead of V should be K here. Sorry. Okay, looks like it's taking long time, so it should get an easy now. Like, yeah. Like the time it took was around 1.84 second was the time limit. I think I would have been able to optimize some more places, but it was not required. And the idea is like similar sweep lane algorithm was also the solution for recent code forces contest. So like nobody is needed. It also had like similar sweep lane idea, which I barely got an AC. Like 6 seconds was the time limit, 6,000 times, and like intended solution I was one short away. So and like I had some ideas for this one, but I don't think I was anywhere close to solving it. So I will skip this as the problem. Any questions related to contest or anything else you want to ask me before I call it a day today? And like thanks everyone who is still here, and thanks a lot for joining today as well. Like shall I start grinding it will, yeah. Okay, like whenever someone wants to ask me like whether they should start with the seat X, Y, Z, like X, Y, Z can be anything. It can be driver seat, it can be CP31, it can be A2OJ, or it can be CSCS problem set. Like I would say like it doesn't really matter which seat you choose. More important thing is like you should keep solving some problems every day. And the critical part is, let's say your rating is 1500 right now, then you should try to solve problems which are 1700, 1800. Like that's the approximate range. You don't really have to be really obsessed with it. Hey, this problem is 1900, so I should ignore it, or this problem is 1400, so I will not solve it. But rather, if you keep doing this part, then at the end of the day your rating will increase. So if you start grinding A2OJ, that would also improve. Like I remember I did A2OJ when I wanted to target for masters. You can start getting A2OJ, or you can probably pick some other seat as well, like if you want, and that should be fine over here. Like if you look at like how A2OJ was generated, the guy what did was like he picked some people in the range, like for if he wanted to create a 16,000 rating problems. Back then code forces problems were not there, problem rating were not there. So he looked at the a time period, and he looked at like how many people jumped crossed that 1600 barrier at that point of time, and then he used some heuristic of what common problems those guys solved, and he did something to get a seat over there. And then he created, hey, these are the 100 problems which you should probably solve it. And like that was a bit heuristic. While if you look at CSCS problem set, it would be like it also has categories, so you can also use it to increase some other problem. Like at the end of the day, it's important what you are doing problems regularly rather than which seat you are solving. So like yeah, you can start with A2OJ. And any other questions? Like I will take a minute or two more and then call it a day. Should I do problem tag wise or rating wise? Okay, like if you really feel like, honestly, I don't think rating is a lot more useful. At least when, let's say, you are still obsessed with it, like if your rating is 500, then if you look at 1900 and you ignore it, then that is not going to help it. What you really need is the approximate range. And like problem tag wise, sometimes tags help as a hint. So you, if you are just starting out, like tags can be helpful, because in the starting, let's say if you are 1200 on code forces, then the tags can help you to get faster, because when you are 1200, like what you really need is a lot of problems to solve, so that you can at least get a hang on of idea what due to A and B are asking. And once you are done with that, then after that, like you can probably go with rating wise over there. And like probably sometimes you may feel that you are able to solve 2000 rated problem if it's greedy or something, but you may not, like you may consistently fail on DP idea. Then you can probably do DP over there. Hey, hi Viraj, I think like you are the Jagu Banda, right? Who wrote this problem. The idea was interesting, and like I don't really know like how to solve it yet. So I will take a look at editorial over there. Like I was trying to do with some strongly connected component, but I was not able to get it. The idea, the problem is interesting, to be honest. And like, but yeah, I want to practice graphs. I was Driver's graph playlist. Like, like the important is like, did you solve the problem related to those graphs which here there? Like for problem set, I can give you multiple problem sets, and like if you want to pick any, you can pick it. I think Shriver also has a seat where he has created some problems. Either you can pick the Shriver seat, or you can also look at Yusav guide. Like here, if you look at it, like there are 4 divisions: bronze, silver, gold, platinum. Platinum is for Div1, and the bronze is like Div4 over there. And like each problem has problem ideas over there and problems there. So you can start from here as well. Okay, Yusav is like it's USA Computing Olympiad. Like there are 4 contests in a year, and they use this contest to select 30 people for their IOI training camp. And from IOI training camp, they take some more contests to select 4 people that would represent it, United States in International Olympiad IOI of informatics. IOI is similar to ICPC, but for school students. So like every year they create this contest. Platinum is used to select people for the camp, but to train other people, they have other division like Div1 to 4. So like they have some contests for every level, and like they create 4 contests over there. That this is USAV, and now USAV guide is the guide, a list of problems which people who have been represented United States in ICPC earlier, or like those who made it to the camp, they came up and they created a list of problems that you should probably solve if you want to represent it United States in USA, United States in IOI. But the idea is like whatever you look like, these problems correlate and can help you even prepare for ICPC as well. Like this is what USAV guide is. So basically a list of topics, a list of problems that appear frequently. The focus was to prepare people for USAV contest, United States Computing Olympiad, but the same problem helps in ICPC as well. Similarly, we also have CP handbook. Like A. Lacosen, I think I hope I'm pronouncing the name correctly. He created this book. It has around 300 pages, and like it also does a lot of topic wise. And he's also the guy who created CSES problem sets. So you can read this book, or and you can try to solve these problems. This also had some standard problems over there. And the guy who has written CP handbook is Grandmaster on Code Forces. And like now there are some like CP book 1, 2, 3 is also there by Steve Helms. So like resources, there are way too many resources. Just that you can pick whatever you use and solve it. Yes, I use Arch, by the way. It's Arch with i3 window manager. So like any more questions before we call it a day? I have an internship drive in 3 months. I am 1100 rated on CodeForces. Should I solve topic wise like DP graph on CodeForces, or should I do lead code? Like whenever someone asks me for some advice, and like if he's looking for an internship in next 6 months, or like a full-time job in next 6 months, I recommend them to solve lead code rather than CodeForces. And I have a reason for it. Like because like lead code sometimes tries to create problems like in online assessment tests before. And like when you are looking at lead code, like you can also look at discuss to find problems similar to which company you have tests similar to. And basically the idea is like if you need something, a job or something in next 6 months, CodeForces can be a overkill. And like the reason is like you have to solve 1,000 problems to get the same result, 1,000 problem on CodeForces to get the same result, which you can get by solving 200 or 300 problem on lead code. And because you are short of time, it's better to solve 300 problem on lead code than trying to solve 1,000 problem on CodeForces to get the same result. While if you are in the first semester or second semester, I would recommend try out CodeForces CodeChef at Coder. If it doesn't works out, then you can always go back to lead code. You have enough time for it. And like that is my reasoning why I recommend anyone who asks like if they want a job or internship in next 6 months, what should they do? Like here, like if you look, you can find one Google interview problem which was asked in some of the contests, and like if you have solved this problem, you would have been able to solve this problem right now. So like my only reasoning is like it's high probability to get a lead code problem which you have solved today to get it in interview tomorrow, rather than when you compare the same probability for CodeForces. Okay, I can solve 2 problems on average on lead code contest. My rating is 1650. Sometimes I solve third or fourth problem of lead code, but once in 4, 5 contest. Okay, like then like the next idea I recommend, like when people say like they want to do lead code and what should they do? I think lead code has one problem of the day or something similar. You should first start solving it. Like, and there are a lot of YouTubers which create a videos on them. That will bring in consistency that you solve at least one problem every day. And now when you want more, but like there is one, I think, neat code to identify guide. You can start with this sheet first, like a blind 75. I don't remember whatever this name is. Like there are some sheets like this. And if you are short of time, you can start with these sheets. Like Liquid also had like top 100 easy. Like lead code also has some sheets like top 100 like problems and top interview problems. Any of these sheets and you can start solving it. And that would be the way, like the only way to get good at lead code problems is by solving more lead code problems. So like you can pick sheets like this to get more in depth over there. Like there are lead code curated as well. You can pick any of them. You can start with one. And let's say you have solved 75-80% of the problems from the one sheet. Then you can probably try to optimize the remaining problem, or you can just switch to another sheet. That would also work. And because like lead code has 3,000 problems, just randomly solving 3,000 may not lead you to anywhere. And like that would be the way you can start solving lead code problem. And like once you think you are good at solving problems, but like 90 minutes contest is a problem where you cannot solve it, then you can keep practicing virtual contest on lead code to get to the speed you need as well. And like that would be the idea. So like the way I recommend is pick one lead code sheet and start solving it. Once you solve 70-80% of the sheet, you can pick another sheet from the lead code related problem. And like that would be the way. And like it's highly recommended that you solve that lead code problem of the day every day to at least keep some consistency, and you solve at least one problem every day. And like that would be my advice over there. So like any more questions before I call it a day today? What are your thoughts on Devin Brown? I would say like let's just wait and watch. Like I'm not really sure like the model is enough to replace SW, but I am hopeful that in future there may be a model like that. So if I'm working right now, shall I keep on doing CF? It depends. Like my advice would be same. Like if you are planning to switch in next 6 months, you should probably switch back to lead code. Or otherwise, if you are here for the long term, then you can keep doing code forces, CodeChef right now. And like I'm not really sure what your rating is, but if you feel you are a beginner, I heavily recommend doing AdCoder beginner contest. The reason is like ideas I see in AdCoder as kind of standard problems. But if you are, let's say, 1600, 1700 on code forces, then also you will learn something by solving AdCoder beginner contest every week. And it's on Saturday too. Like I would call them not AdCoder beginner contest, but I would say AdCoder educational contest over there. So like I would say definitely start with AdCoder contest, and then you can probably choose CodeChef code forces if you are more time. So like even like I had a stream on these problems last week, and I think I have seen similar problem, like the ideas on all of these problems before. But I believe a lot of people would have seen some ideas for the very first time. Okay, can't solve ABCD because it's mostly on DP. So like that should be a hint AdCode is giving you again. Like you should solve a lot of DP problems to get good at AdCode. Hey, hi brother, is it possible to be like you by consistently solving hard and uncomfortable problems? I would say yes, because that's what I have done. The only difference is like based on the background you have like earlier. Like some people are very good at like mathematics problems because they prepared for Olympiad or they probably prepared for JE. So like it may depend on the time you need. Like at the place where I am right now, like it took me I would say around 6 years to get there. Like I have 2.5 years working experience right now, and I started when I was in my first semester. So, but like if you are sharp at catching thing, you may get at the same place within 2 3 years as well. Like I have seen a lot of people getting like 2400 rating on code process within 2 3 years as well. And like you may like based on your background, the time may vary, but I would say like it's definitely possible because the only way I got here was 2000 problem on code forces, and I think I have around 1000 problem on CodeChef, 1000 problem on AdCoder, and probably some other platforms as well. So I think my problem count would be around 5000. That's when like I never really choose to solve easy problems a lot of time. And like my idea was mostly doing up solving problems and just go there, participate in contests. And like at a lot of time I may have to skip dinner as well. Like today I did dinner after between 10 to 10:30 before this trip and like up solving there. So like I would definitely say it's possible to reach here. And like the time may vary based on what earlier background you have. And like I think this completes my question for today. If there are some more questions, I can answer them or otherwise. Do you have suggestion tips for permutation combination expected related problem? Any good resource? Yes, I have one. Like Erecto has created 2 long lectures which are close to 4.5 hours duration and a lot of problems there. You can first start with these problems. He has defined some things and he have given a lot of problems over there. And then he has a lecture stream over here as well, which you can watch to get some beginner idea, to get some hang on what's going on. Similarly, he has a part 2 as well, which has slightly difficult problems and a lot of problems. So like this can be a starting point to solve expected problem. And then it's mostly about trying to solve a lot of expected value problems. And like those who I believe anyone here would know Ericto, but like let's just say like he was a legendary grandmaster on code forces. and he has around 3,000 subscribers on YouTube as well. Like you can find a lot of quality content there. Like you can go subscribe him as well. Like yeah, right. Nor like I think he's anonymous on code courses, so I won't say his name, but yeah, like he's a guy like who writes a lot of blog and like it's a mathematical blog here. I'm not really sure if he has written a blog on expected value or not, but yeah, if he has written, then you can. A comprehensive guide on permutation for beginner. You can refer this blog. Probability 101, the intuition behind martingales. I don't really know what martingales is, and to be honest, I haven't read this blog as well. Like, although I see a lot of problems like this, find the expected value before XYZ happen. But yeah, I am weak at it. Okay, it's the same, right? Like, you may probably find more, but yeah. Basically, the main idea is keep grinding. At the end of the day, you will get good results. And like, if you look at my all the advice, like whatever I have said boils down to just go there, grind it, you will get the result you want. So like, that's the way. There are no shortcuts here. And yeah, any more questions before we call it a day? Okay, one final question. At your level, does the CodeChef fifth, sixth problem of Div2 seems trivial to you? Like it depends. Like what I have seen is like even the contests which were rated for 5 star, like the last problem, or probably I would say like it's something which gets strike to me like after thinking for 10-15 minutes most of the time. I'm talking about Div2, like if it's Div1 and rated for all, then last three problems are most of the time out of my reach. And if it's rated till 6 star, sometimes one or two are out of my reach. But if it's rated until 5 star, most of the time it's last one problem or something like that. How to be better in competitive programming? Or give some tips like, okay, like this is a generic question which a lot of people ask to me. Like what I am trying to do over here is like for all the questions like this, I also have a Discord server where I have this channel roadmap to read in 2 minutes. It's a clickbait channel, but here like I have some questions like how to be better at computer programming. Like I have tried to answer like what I feel the answer should be. Like for example, if your question is like if you are looking at how to solve get good at some topic X where X can be DP, then I have suggested some way to look at it. How what should I do to reach expert? Like I have some suggestion for them. I have some suggestion like how to reach candidate master here as well. And then I am planning to write what I did for the next part as well. So like you can first refer to this server. And if there is something which I did not answer over here, then you can probably ask me in this Discord server. I will try to answer it. So like you can join this Discord server. Like the link is in the description here. Okay, sir, I can solve lead code problem, but I struck on code forces CodeChef. Okay, like basically, I would say like if you rate all the problems based on difficulty, then like at Coder grand contests are the one which have most difficult problems. Then ARC, ABC, and somewhere like. So what it relates to is like lead code first four problems are most of the time until code forces C problem. Sometimes the fourth problem turns out to be D or E somewhere. And like so like if you are able to solve problem, then I think you are doing good. And at least if you are trying for some placement or some internship, you should be able to crack a lot of online assessment tests. But if you want to be good at code forces and increase lating there, then you might have to solve more code forces problem. Can we use DP to solve ABC conjecture problem? I don't think we can use DP there. Yeah, I don't think we would be able to use DP here. So yeah, that is right. Because like the constraints are up to 1e5, and if even if you have two DP dimension, both of them would be up to 1e10 or something like that. So yeah, that is right. Any more questions? Okay, good night everyone, and thanks a lot for joining today.